Chapter 15, Probability Rules. The general addition rule. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Remember, that means intersection. Example. When drawn a card from a standard deck of cards, what is the probability of drawing a jack or a club? So the probability of drawing a jack or a club would be the probability of a jack plus the probability of a club minus the probability of a jack and a club. So this would be 4 over 52 because there's 4 jacks in a deck, plus 13 over 52 because there's 15 clubs in an entire deck, which has 52. And there's only one jack that's a club, so we'd have to subtract 1 over 52. And that would give me 16 over 52. And you can leave it like that, or you can reduce this to 4/13. Example, in our class of 36 students, we found that 25 students like to listen to rap music, 22 students like to listen to alternative music, and 16 students like to listen to both rap and alternative. So what we need to do here, because we want to find the probability of these events, it's best if we draw a Venn diagram. So first we need to state what everything's going to be. So I'm going to have section A and section B for the probability of A and B. A is going to be rap. B is going to be alternative. And the first thing we want to do is we want to start from the inside out. So there are 16 people that listen to both. So we would have 16 in the intersection of A and B. Then there were 22 students who like to listen to alternative music. Already in section B, we have 16. The whole section B is 22. So 22 minus 16 will give me 6 that are just alternative music. And here in A, it said that 25 students like to listen to rap music. We already have 16 there. That means 9 only like to listen to rap. Let's add these together. 9 plus 16 is 25. Plus another 6 is 31. So that means 5 don't like to listen to any types of those music. So find the probability of the following events. The probability someone likes to listen to rap music. So the probability of event A would be 25, because 25 people like to listen to rap music, out of 36. And then a student likes to listen to alternative music. So the probability a student likes to listen to alternative music would be the probability of event B, which is 22 out of 36, which can reduce to 11 out of 18. So the probability of A or B. So the probability of A or B. So the probability that you like to listen to rap or alternative. Okay, that would be 9 plus 16 plus 6, if I look at my Venn diagram, all over 36, which equals 31 over 36. And the probability of A and B, a person likes to listen to rap and alternative music. So the probability of A and B would be the intersection, which is 16 out of 36, which will reduce to 4/9. Let's go ahead and describe the following events. A complement. These are students who don't like rap. B complement are students who don't like alternative. A complement or B complement. These are students who don't like rap or don't like alternative. An A complement and B complement are students who don't like rap and don't like alternative. Let's look at conditional probability, a probability that takes into the account a given condition. The probability of event B, given that event A has occurred. Also stated the probability of B given A. And this is given by the probability of B given A is the probability of A and B divided by the probability of A. Let's look at an example. When drawn a card from a standard deck of cards, what is the probability of a jack given that you have a club? So this is the probability of jack given that you have a club would be the probability of jack and club all over the probability of a club. So a jack and club is only 1 out of 52. Probability of a club is 13 out of 52. So the probability that you have a jack given that you have a club is 1 out of 13. If events A and B are independent, then knowing that event B will occur does not change the probability of A. So for independent events, the probability of A given B equals the probability of A. Let's look at this example. When flipping a coin twice, what is the probability of getting heads on the second flip if the first flip was a heads? Event A is getting head on the first. Event B is getting head on the second. Events A and B are independent since the outcome of the first flip does not change the probability of the second flip. So the probability of B given A equals the probability of B, which is just 1/2. What happens when events aren't independent? If knowing the outcome of event A changes the probability of event B, then event A and B are not independent. And you would use the general multiplication rule. The probability of A and B equals the probability of A times the probability of B given A. Notice that the conditional probability rule has been rearranged. And this is always true. Conditional probability with tree diagrams. Only 5% of male high school basketball, baseball, and football players go on to play the college level. Of these, only 1.7% enter major league professional sports. Although it is unusual for athletes who do not compete in college to go on to professional sports, 0.01% of those high school athletes go straight to the pros. So we're going to define our events and then draw a tree diagram of this. Event A is athlete competes in college. Event B, athlete competes in pros. So now we're going to show the probabilities in a tree diagram. So the first thing is, does the athlete compete in college? So that would be A and A complement. So the probability that the athlete competes in college would be 0.05. The probability that they don't is 0.95. So from here, you would compete in the pros or not. So the probability that we compete in the pros would be B, and not would be B complement. And that would be 0.017 and 0.983. Then if you don't compete in college, the probability that you compete in the pros is a lot smaller. So we have B and B complement. And the probability that we compete in the pros is 0.0001. And the probability that we don't compete in the pros is 0.9999. So here we have our probabilities. We have the probability of A and B, which equals 0.00085. Then we have the probability of A college only, which would be A B complement, which would be 0.04915. The probability of only pros, which would be A complement intersect B, which would be 0.000095. And the probability of no college or no pros, which is a lot of the population, would be A complement intersect B complement, which would be 0.949905. Okay, so when you make a tree diagram, a lot of times it's best, and you go across, probability of A and B would be 0.05 times 0.017, and that's how I get my 0.0085. You multiply going across, following the branches. We would multiply the probabilities we have there. So let's go ahead and try to answer these problems. Given that the athlete competed in college, what is the probability that the athlete competes in pros? So this would be the probability of B given A. So this would be the probability of A and B all over the probability of A. So we would go back to our tree diagram and use the probability of A and B that we found here, divided by the probability of A, which is right there. So this would be 0.00085 all over 0.05, which equals 0.017. What is the probability of selecting an athlete that competed in college and also competed in the pros? So this would be the probability of A and B, which we found using our tree diagram, which was 0.00085. Given that the athlete competes professionally, what is the probability that he competed in college? So probability of A given B. This would be the probability of A and B, all divided by the probability of B. We know the probability of A given B is 0.00085. And the probability of B would be A and B. So if we look back here, so given that he competed in college, so that would be here, they competed in college, it would be our 0.00085. And then right here, they also competed in college, so it would be 0.000095. We would add those together, and that would become our denominator. So it would be 0.00085 plus 0.000095, because you have two places where they competed in college. And this is about 0.899. Add the following branch to your tree diagram. About 40% of the athletes who competed in college and then reached the pros have a career of more than 3 years. We're going to add C, athlete and pro, for more than 3 years. So the athlete and the pros for more than 3 years. So we're going to go back to our tree diagram. And this is one who competed in college, then reached the pros. So competed in college and the pros would be right here. And from this, you would have C and C complement. So more than 3 years, not more than 3 years. And this would be 0.4. So this would be 0.6. And then when I multiply these, this would be the probability of A and B and C, which equals 0.00034. This one would be the probability of A and B and not C, which would be 0.00051. So let's look at this problem. What is the probability that a high school athlete competes in college and goes on to have a pro career for more than 3 years? And that would be the probability of A intersect B intersect C, which we found to be 0.00034.